Happy Friday. My name's Simon Timpley from the International Food Safety and Quality Network. Welcome to Food Safety Fridays. This week, we've got 3 easy steps and 2 tools in root cause identification for your food safety management system with Vladimir Suchinsky. I'll be introducing you to Vladimir shortly. I'm sure many of you already know Vladimir very well. He's done lots of webinars and he also does some training courses with us as well. So good morning, good afternoon, good evening, wherever you are in the world, you're all welcome. Just to say, obviously a lot of you are already typing in the sidebar and saying hello. Yeah, please do that. That's also for your questions later on when we do the Q&A. So try and keep your questions till the end, or else they will get lost. But yeah, that's for typing your questions. It will be recorded. It is being recorded today, as ever, and we'll follow up afterwards with an email with the video recording, the slides, and your certificate of attendance. So if you do need to disappear for a little while, or you have an outage or whatever, don't worry, you can catch up with the recording later. We are sponsored. Food Safety Fridays is kindly sponsored by Safe Food 360, Trace Analytics, AIB International, DNV GL Business Assurance, and Mettler Toledo. And they've been supporting Food Safety Fridays for a number of years. And I'm now going to play their adverts. I'll be back in 2 minutes.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, that was the sponsors. Right, back now. I've just loaded the sidebar, by the way. Next Friday, we've got practical HACCP training 4-hour webinar. So if you need a refresher or your HACCP team have not been trained, get them on board and get some of that training and get them a bit of education on HACCP. Anyway, you can click for more information there. Now I'd like to introduce you to our guest presenter and good friend, Vladimir Suchinsky. Are you there, Vlad? Good. Nice to see you. And you've been up.
Nice to see you too.
You've been up very early this morning. Is it 4 o'clock you
Yeah,
was up? And
I had 1 hour to perform and then came back to have this webinar.
so you even get up at 4 o'clock in the morning to get an audit done so you can be with us today. So no, we really appreciate that, Vladimir. So no, thank you very much. Okay, well, I'll load the presentation and I'll be back for some polls and the Q&A later, but I'll hand it over to you.
See you.
Okay, there you go.
Okay, thank you. So, hello to all food safety friends. Thank you for logging into this presentation, and thank you again, IFSQN, for this great opportunity, giving all of us place to share and to learn all these interesting things about food safety. And special thank to you, Simon, for being our host for these great webinars. I know it's not easy always to handle all these things about this, online softwares and everything. Okay, so practically, a lot of you already know me from previous webinars since I started presenting for IFSQN from 2015. Till now, we have talked about the topics of different kind of emergency preparedness, traceability of food in restaurants, fast food, also some interesting topics like safe food versus healthy food, some very interesting topics about defining objectives in food safety, etc. And in previous period, one of the most tracked topics was FSSC 22000 version 4, but focus on management of purchase services. All of these presentations, you can find it on IFSQN. I'm a certified food safety expert with more than 10 years in food safety topics and more than 8 years in implementation, training, and auditing business. Food safety standards are my focus, but still strongly included in standards for quality, environmental protection, health and safety, business continuity, and risk assessment. Currently, I'm in a position of project manager for certification body of Quality Austria, where I'm also accredited auditor and trainer with more than 500 audits performed in different industries and more than 1,000 persons trained. I have some vision of finding a new ways to analyze risk in food safety and defining of methods that will be used in industries across the world. My strategy is just to develop and research new topics in food safety, presenting them through the webinars, training forums, blogging, and publication. There is also a new thing, and from the beginning of the year, I started my own vlog. It is called Addicted to Food, and it is focused, of course, on food safety topics, and it is available on LinkedIn and on YouTube. So if you would like, go there and you will find me. For the beginning, to remember that future has to do with the character and competency. Who is lacking the one or the other or both will never go beyond the present. So please use this presentation for building your competencies. Click the links provided for future trainings and go beyond the present. Okay, let us start from just describing some of the total quality management tools and try to explain them. So in this definition, it is said that total means quality management involves customers, employees, and management, as well as all tasks and activities of company. When we talk about quality, this is practically the degree to which the product or service meets the customer expectations or was produced correctly. When we talk about management, quality must be managed by planning, organizing, leading, and controlling. And total quality management is an integrated management philosophy for continuously improving the quality of products and process. Why we are talking about this? Because the total quality management system model is covering 5 areas that is very important for you if you're working in production, etc. So here practically you need to focus on 5 areas like customer focus, planning process, process management, process improvement, and total involvement. This means the total quality management covers leading with objectives, it covers customer-oriented, it is internal and external customer relations, zero error program, work in process, continuous improvement with measurable units, involvement of all employees, trainings and further education, and frequent management audits. 7 classical tools of quality that are used are, and this is the most common quality tools that can be used to solve the vast majority of quality related issues. But again, they could be used to collect the basic risk and to find the root causes and practically to analyze risk assessments and to analyze all of your corrective actions. So here the 7 classical tools are Pareto chart, scatter diagram, control chart, flow chart, cause and effect, histogram, some checklist or check sheet. So today we are focusing on cause and effect diagram and some common use check sheet like FMEA that we are going to talk about in next part of this presentation. So practically these are only the 2 tools that we are going to talk about. Constructing cause and effect diagram can help us when we need to identify the possible root cause, the basic reason for specific effect, problem or condition. To also, we can use it to sort out and relate some of the interactions among the factors affecting a particular process or effect. So analyze existing problems so that corrective action can be taken is also part of this cause and effect. And again, later we will talk about some simple use of FMEA through the really practical example. We set up some additional tools as Simon described to you, and we have one question first for you. So we kindly ask you to respond to the same in your chat bar. So which tools of quality have you already used from the mentioned one or some additional? So please, if you use some of the quality tools, please just type in the chat bar.
Oh, there you go. Chris,
All 7 of them. Nice.
all 5 Ys.
Oh, nice.
Flowchart, Fishbone, Pareto checklist,
Nice,
5 Ys.
nice.
All.
Okay, perfect.
Lots of users. Yeah.
Yeah, nice, nice. Okay, this is very nice because then you're really going to like the project that we used these two analyzers like Fishbone and FMEA and how we managed to do it in the same time. Okay, so we are continuing. But before we go to the next slides, I would just actually today's presentation is just one part of the bigger one that is focused on processes of root cause identification and problem solving tools in food safety. And we are organizing this webinar on the 31st of May. And in this presentation, we are going to talk about additional tools like Pareto and 8D. And we will go more in details regarding Ishikawa diagram and FMEA. So if you are interested, you will have a link inside offers and you are all welcome. So we can see and continue on the 31st of May. Okay. So today this root cause analysis is focused on measures to reduce the risk of contamination, and same is done in real condition and realistic situation with the company that is one of my clients. And here we will focus on molds on dry sausages. Actually, when we look at it, we are going to talk about root cause analysis and measures to reduce the risk of contamination. For the purpose of today's presentation, I made this webinar as a project work. And through this project work, real life example is used to show how root cause analysis is done and what measures are taken to prevent once a big issue of molds on the dry sausages. Example is provided by company from Serbia, and whole process is analyzed by the author of this presentation together with the technologist and production manager of the company. Company is chosen because of most idealistic infrastructural and equipment condition, knowledge and experience of the food safety team. And during these processes, a number of tools is used like Ishikawa or FMEA to just show root cause analysis and to show how problem is solved and prevented to happen in future. But are the molds a real problem? When we look at the molds, they have their own negative sides, like mold growth on the surfaces of sausages is generally undesired because of the looks, because it can make you sick, etc. Also, growth of some cultural molds like penicillium on other dry sausages that that they are not meant to be molded can be seen as a problem, you know, because of the look, because of everything. And also it could show some unsuitable storage conditions such as high humidity and temperature. It can affect the surface stability of the sausages, and mold spores can germinate and grow on them. The growth of molds can be inhibited by air circulation and the presence of fungicide compounds in the smoking medium, for example. And also, for example, in North America, there is generally consumer reluctance to purchase moldy food items, and dry sausages do not appear to be an exception. Although sausages evenly covered with dense white mycelium are considered desirable by some groups, the uncontrolled mold growth seen on most dry cured meat products usually pigmented green, gray, or yellow, and thus has little appeal. But what are the positive sides of the molds? Dried sausages with various degrees of surface mold growth are preferred by ethnic groups from many countries, especially in some regions in European Union. Moldy covered food products are not so desirable for consumers in Serbia, for example, and the part of the region. On the other hand, there are products like some types of fermented sausages, that is called winter sausage, that consumers are familiar with and aware that same is covered with the molds. So if you are aware, then this is not a problem, of course. Also, some traditional produced cured meat, like hams, are considered high quality if they are old up to 2 years and covered with the molds. The relative prevalence of mold strains growing on casings depends on the type of sausage, the area of production, and the technological parameters of production. These parameters include water activity, include humidity, temperature, and the relative humidity of the drying and ripening steps. But in this case, molds were a real problem. Majority of complaints were regarding the noticeable white molds on surface of sausages that are packed in vacuum packaging like Srem sausage, and company experienced a number of customer complaints in period of 2016 and 17. Mainly complaints came seasonally in some periods from May to September. Majority of complaints were regarding only this vacuum packed sausage. And since companies producing private label products for big retailers, this compliance did not pass them also, and recognizable brands were also included in this compliance. All of the compliance were followed with returns and substitutions of the products, which had further effects on transport expenses, storage and display expenses, and in cases of big retailers, also some penalties followed. Return products were sent to laboratory, and results showed that the same had surface molds of penicillium, and which means that this could not have potential health effects. Let us look at the production conditions. So this is a small company that is located on a mountain with really specific air. The location of the production is in an area that is not surrounded but by some other productions that could influence these processes. Also, the layout of the production is all in very good way planned. Equipment used in the production is from very suitable materials like stainless steel materials, very easy to clean surfaces, etc. Work surfaces are in very good condition. Maintenance is done regularly, and all the changes that is needed. When you look at the containers, when you look at the internal transport, everything is done according to regulative, but also according to the standard demands, because this company is certifying one of the GFSI standards. Next thing is this hygiene maintenance that is really on a high level. If you look at the cleaning of the all surfaces, the disinfection process, the cleaning out of place, the use of the appropriate cleaning agents and everything, it is really good hygiene practices. Also personal hygiene. If you look, this is high degree level hygiene area, and all employees need to wear to wash their hands, of course, and to wear gloves and to wear hairnets, protective masks and everything, and they even have to change the clothes before they enter this area of final slicing, vacuuming, etc. Also, awareness trainings are very regular, and for this company, awareness is on a very nice and high level. Pest control activities are regularly done, no any issues, waste management done in very correct way, and also regular. Regarding the reception process, storage, defrosting, processing of meat, drying, smoking, fermentation, then storage of finished products, then processes of slicing, packaging, vacuuming, everything is really good explained in work instructions, and all the employees are trained in a very good way. So for the beginning, it was very hard to find where the issue came. When you look at all these good hygienic practices, good production practices, production conditions and everything, it was very hard in the same time to see where the problem started, where these molds could develop, and how they developed in a packaging area, and also how they developed later on and showed on the products that are vacuum sealed. But to be sure and to find out, we use 3 steps, and this is 3 steps that you should use in really defining the root cause. The first step is to define who will be responsible team for use of the tools. And this, of course, depends on the type of the problem. It depends on the size of the company. It also depends from the knowledge of the employees, and of course the knowledge of the tools that you're going to use. And hopefully you are going to learn today these 2 tools, so you will be one of the employees who will be part of this team. So first step is to define who will be responsible team for use of the tools, and it is really important that you do this in the team. The second step is to define which exact tools fits best for your case. It depends, of course, on the type of the problem, it depends on the time, and also the knowledge of the team members. Sometimes you will have a short time period to really use some fast tools to define, like, for example, someone mentioned that they were using the 5 whys, and the 5 whys are very fast tool, very descriptive and fast tool where you can find the root cause. Also brainstorming, when you have a good meeting and you brainstorm what could be a root cause. But let us stick for this time on Ishikawa diagram. In this case, this is a smaller company, does not have a lot of employees. All the employees are very good trained and very good awareness. They needed some of the tools to be used, like, for example, Ishikawa, that is more visual, and later on some detailed and logic use of FMEA. And third step is practically to implement the defined tools and actions that comes after the use of these tools. So first step to define the team, second step to define the exact tool that you are going to use, and third step is to implement this defined tool. The 2 tools that we used in this case, so for specific mold issue, company analyzed customer compliance together with the recorded non-conformities by employees in production that noted growth of molding during fermentation process in storage. So in first step, company considered that hygiene is not good enough and improved the hygiene of production and packaging area, but this had small effects on growth of molds and number of recorded non-conformities. So the first step company used is, okay, let's speak with employees from production, with operatives, let's speak with production chief, with the technologists, and the first they used something like brainstorming and came to a conclusion, okay, maybe hygiene was not good enough, and they improved the hygiene of production and packaging area. But again, this had small effects on growth of molds, and number of recorded non-conformities were not so had not so big changes. So company mainly here focused on solving the root cause, thinking that this was a low hygiene standard. Since issue was not solved, it required the use of additional tools to come and find the real root causes for molds and sausages. Here, two tools are used. This one is Ishikawa diagram or Fishbone diagram to try to find all possible root causes, and later on, for all root causes, FMEA is used to present how risks are and which steps to use to prevent them. At the end, action steps are included in this FMEA, and we will show it later on. So our first tool is practically for all of you. Have you ever used the Ishikawa or Fishbone diagram? We saw that some of you have used a little bit of these tools, but this is question for all regarding just the Ishikawa or Fishbone diagram. So if you can just go to the additional pool.
I've loaded that, Vladimir. And you would expect from the comments before that lots of users of the 7 tools. So roughly two-thirds have used Ishikawa, Fishbone, cause and effect, whatever you want to call it.
Yeah. Okay. Okay, so yes, 65% have yes used. Okay, so generally, why should we use a cause and effect diagram? So this is a tool that is useful for identifying and organizing the known or possible causes of quality or the lack of it. The structure provided by the diagram helps team members think in a very systematic way. Some of the benefits of constructing a cause and effect diagram are that it helps determine the root causes of a problem or some quality characteristics using a structured approach. It encourages group participation and utilizes group knowledge of the process. And also it uses an orderly, easy to read format to diagram cause and effect relationship. It also indicates possible causes of variation in a process. Increases knowledge of the process by helping everyone to learn more about the factors at work and how they relate, identifies also areas where data should be collected for some further study. So in this case, we use the Ishikawa diagram or Fishbone diagram, and actually I'm going to show you on the next slide just the picture of the Ishikawa diagram that we used. Actually, it was written in Serbian. We just put it in the English, so it will be easier for you to check it. So we used this Ishikawa diagram with the 6 practical parts that we analyzed, and these are the methods, the measurement, the machine, management, and material. And we try to find some of the causes. And here, important to mention that part of the team was also employee from the top management. Then there were technologists. Then there were employee from the operator, and also me as some external help. So we used a really big piece of paper, trying to put everything, and the red things that you can see are measured as the most, let's say, the most important things that could be real causes of the molds in this Sremska sausage. So I will not go through all of them. I will just mention some of them. If you look in the part of the material, here we talked about, think about water, we were talking about casings, about additives, etc. But again, this was the vacuum packed products. So at the end, we agreed that the problem could be with the type of the foils that we used, and we just put this as possible cause. Then again, if you look at the men as employees, we talked about some trainings, we talked about some production rules, maybe they were not good, etc. But at the end, we came to the possible cause, that is personal hygiene, and practically that it is connected with the work uniforms, where we said that maybe work uniforms were not washed in a proper manner, and then that molds comes from these work uniforms. Also, we talked about some machine. Let's go over there. And here we talked about vacuum packaging machine. We talked about chamber for smoking of the and fermentation of the product. And also we talked about processing equipment that is in contact with the product during whole time, from raw material till the end processing equipment. And here we said that possible causes could be maybe the chamber, maybe the hygiene of tubes through which smoke is coming were not very good, although we knew that the chamber hygiene, walls, floors and everything was really in a good level. But then we talked about processing equipment that is in contact with the food, and here something that we noticed is the moving of the crates. As the movement of the crates was like we were pushing them or strolling them directly on the floor, there were some small damages on the crates, and we were thinking maybe the cause are these smaller damages where dirt can build up, and later on during the cleaning that this is not sufficient to remove this dirt from these smaller parts. Of course, we talked about some causes in measurement. We talked about some causes in the methods that could be a root cause for our molds in Sremska. At the end, we decided that let's say that all of these are root causes, and we will try to remove every one of them. And with the removal of every one of them, we will remove, of course, the effect, and this is the molds in Sremska. Okay, so after this, after a discussion and everything and putting it into Ishikawa diagram, again we come back to the second tool, and for the second tool we used about for this specific mold issue, we analyzed additionally customer complaints together with recorded non-conformities, etc. Came back to that, and again we said, okay, we found the root causes, possible root causes in the Ishikawa, and let us use some other tool to really calculate the risk of these root causes and how we will remove them. So next, practically, is one tool also for you. Have you ever used FMEA in this case? So there is a pool again for you. If you can just type it.
Yep, polls in the sidebar. What are you expecting to see, Vladimir?
I don't know, maybe because, you know, Ishikawa diagram is very easy to use, Five Eyes brainstorming is easy to use, and FMEA, it consumes time, you know, not just to, you know, you have to put everything in some type of table or check sheet, then you have to discuss about it, then your team needs to really make sure that they agree about the levels of the risks, etc. And sometimes it is not, because of course it is time consuming in the production, sometimes it is not always used, you know. Let's be more focused in production to some fast tools, you know. But FMEA is one of the tools that you can really finish everything and have like some logical thing to your root causes.
Yeah. Well,
okay,
it won't surprise you to see then that only 26% have used it and 74 have not. Yeah.
Okay. So it would be interesting for you to see how we used all these conclusions from Ishikawa in the FMEA. Okay, so practically what is FMEA? So for sure use of the analysis methods like FMEA, this is important methodic instrument of reliability technology, and it is used to detect some possible product and process errors and their causes and consequences at some early age. In this case, this was not early age, but early stage, but we at the end use it, you know. So these early stages are developed and planning phase of new product and process, and FMEA within quality and safety management is applied to increase technical reliability, especially in these mentioned stages. Again, it is not just that you can use it in this first stage, you can use it later on also. So possible errors here are evaluated with a key figure regarding their relevance for the customer, their probability of occurrence and detection. Important to mention that there is like some 3 key figures that is used here, and these are the probability of occurrence and of course detection, and here also FMEA is used to monitor the maturity level of product and process, and is therefore an important managing instrument to support some interdisciplinary teamwork. So this is practically one of the FMEA form sheet. I'm sure that you can find a lot of different FMEA form sheets on the internet. And here I will just for the first step explain you how this form sheet, what are the main parts. In the above or the first part, you can see that this is FMEA form sheet that could be used for the evaluation of root causes for some processes in your company. These processes could be the purchasing process issues, the sales process issues, etc. So you can use this process FMEA for the issues in your processes, but also for the issues that are connected with the product. So this time we use it as a product FMEA because we had, let's say, mix, like we had some issues with the processes, but we also had some issue with the product. Also, you put here the name of the company, the name of the product, the names of the employees that were included in the team of FMEA, which is the first step of this analyzing tool. For you to see, there is a lower part with some tables, and you can see that 3 measures that are, let's say, evaluated are the probability of occurrence, and here probability of occurrence is evaluated like unlikely or low or moderate or high. The next thing is that you evaluate the effects for the customer. So here they are evaluated as hard recognizable, unimportant error, moderate severe error, and very severe error. And the third thing, as you can see for these 2 evaluations, they are similar as you could use it in your hazard analysis, where you mainly use the probability of occurrence and effects for the customer, meaning occurrence and significance. But the most important thing in FMEA is this third measure, and this is detection or the probability of detection. Here you evaluate, do you already have some kind of tools or some knowledge or processes that you can really detect the problem. So here probability of detection is evaluated with the high, meaning that you have every tools to detect the problem. Then there is a probability of detection that is moderate, low, very low, and negligible. If you calculate these 3 measures, you get risk priority number. So risk priority number is the calculation of these 3 measures. And here overall risk of one error cause is evaluated with the high, that is higher or equal to 1000, then medium, that is lower or equal of 250, and low, that is lower or equal to 125, and none in cases that it is evaluated with 1. So according to this legend, we are going to start with the first one, and here we are going to talk about error location and features. And here you can see that plastic crates are in contact with the products. As you remember in Ishikawa, we mentioned that there are some plastic crates that are in contact with the products. Potential error here is that cross-contamination from inadequately cleaned crates from cross-contaminated work surfaces. Error consequence is that product contamination with molds or other microorganisms. Error cause is that crates are pulled directly on the floor, causing small damages in the plastic. And because of this, we could not perform very detailed cleaning. And because of this, we had probably development of the molds on work surfaces. So we evaluated here probability of occurrence with a 7, which is high. Also significance, we evaluated with 6, which is moderate severe error, and detectability or detection with 8, meaning very low, because we didn't have any measure to detect are these really small damages affecting the work surface and influencing the development of our molds. So again, risk priority number here is multiplied, and then you got the risk priority number that is 336. And here in these cases, this 336 is a high risk, and because of this, meaning medium risk, and because of this we needed to respond and to lower this risk. So we proposed some measures. All the team proposed some measures. The measures were to make conveyors for transport, to change rules for handling and have no contact with work surfaces, and to regularly changes of damaged crates. And responsible here was quality department and also employees. The measures that we have taken is that we bought 10 conveyors. Also, some work instructions in packaging area are changed. Additionally, employees are trained for this. And again, we have done the risk analysis. And here we said the occurrence now is practically very low and evaluated with 2. And practically, this is because we implemented all the measures. Then significance is not so changed, because if it happened, it could have again effects for the customer that are similar. But here it is important, the detectability or detection is changed, because now we have tools to really detect this. Practically, we bought 10 conveyors. We have no more damages in the practically these crates. And in cases that crates, we bought new crates, if you turn the crates, there are no damages, and it is really easy to detect. When you do your calculation, you get that the risk priority number in this case is 24, which is very low, and for us, we removed this root cause as a possible. We implemented some measures and removed the root cause, that is plastic crates that are moved directly on the floor. Then second root cause that we talked about are the fermentation chambers, where we said that fermentation chambers are not sufficiently clean. And potential errors is that buildup of dirt in air systems. There are some tar from smoke. And here error consequence is that moist is not adequate, changes of air is not done properly, making some ideal conditions for development of molds. Cleaning of chambers and chamber system is not sufficiently done is our error cause. Here we talked about control measures. Again, cleaning is done according to defined plan every 2 weeks for air system, performed with chlorine-based cleaning agents, and there are visual control of cleanliness. Again, we evaluated with 252, which is some high risk, and this high risk demands of us to go on some action. Actually, as this is a question from Juliana, does the RPN determine the priority of actions? We decided that in this case, if the risk priority number is medium or high, we need to take some measures. In this case, in other cases, you can say that only risks that are higher can be measurable, or you can take some or propose some measures. So it is up to you and your team to decide. In this case, we decided that if it's medium or it is different, then it is higher. We need to perform some measures. In this case, for second part, we perform cleaning once per week of whole air system, removing the complete tar. We use of different cleaning agents, and this is a type of peracetic acid based. And here responsible persons are production manager, employees from the production. Taken measures are that we have done cleaning once per week with complete opening and cleaning of air system. Cleaning agent is changed, and employees are additionally trained for new cleaning procedures. After the evaluation, we got the risk priority number is very low, and we removed also this as a root cause. Okay, I will go to one other that were not so big evaluated, and it was the employee work clothes. It is under number 4, as you can see. And here we thought that work clothes is not washed according to procedure. Maybe there are dirty clothes and some cross-contamination, and washing and practically ironing procedure is not adequate in this case. And we said that we only have one control measure, and this is visual controls that are done daily. So after evaluation, we had the risk that is very low, and practically we could say that no actions are needed in this case. But again, we sat and said, okay, let's see, can we maybe improve also this process? And we said revision of procedure for uniform washing and ironing. So we revised the procedure, and also we implemented higher probability of detection with the external lab verification of our washing. And we got a really, really low risk priority number in this case. And because of this, we practically remove also this root cause. So I will not go through each step that we have done, because later on you will have this presentation and you can really go through this and contact me. I will go to the one that is very interesting for you, and this is on our next slide. So here practically we have thought about smoking process. So smoking process, we talked about potential errors, and this is that moist is coming with the smoke in chamber, which affects total moist during processes. Error consequence was that moist is not adequate, it changes of air is not done properly, and it makes ideal conditions for development of molds. Error cause was the process of preparation of sawdust and failure in software for moist control. So first, our control measure is that we have a software that is controlling process through the measurement probe in chamber. And we said, okay, when we look at detection, we said this is very low detection. We have some software that is controlling the process through the measurement probe in chamber, etc. After we calculated the risk priority number, it was really high risk priority number. And then we propose some measures like to check the software measurement tool, updates of this version, also to control of process of preparation of sawdust. Here taken measures is that we software is not tracking the process of smoking. This is something that was concluded from the taken measures. Also controls are implemented for adding of sawdust. Employees additionally are trained, but again, after we concluded this risk priority number was still high. It was 3 to 4 because the issue was our own software. So what we have done, we have again step with the smoking process where we said that potential error was that water activity moist is not under the control. Error consequence is that moist is not adequate, making ideal conditions for development of molds. And error cause is that software does not control moist during smoking process. Programming the process was wrong. Here control measure is the software again controlling the process like in previous one. Risk priority number just moved from the previous step. And we propose some measures like to update of programs and to perform the verification of the process. Some of the taken measures are that program and software are updated, now tracking the smoking process, and the verification is done externally, included some quarterly service. And with this, we totally removed this root cause to the risk priority number that is low and that is not important to us. As you could see from this whole FMEA, we practically removed all the red root causes that are mentioned in the Ishikawa diagram, and in future steps of production, we had no any molds in the products, and we solved our issues with customer complaints, with the big retailers, with everything practically. So with this, we are finishing this FMEA. This template will be available for you in the presentation, and you can read it detailedly. If you need some additional information, please do contact me. So with this root cause identification and problem solving tool, information for you is to get to know all additional tools. Informations are available on the FSCOM website or contact your web trainer. There are some changes. Think about easy use of the root cause tools. We can help you with the implementation of minimally 4 tools. Visit and download. These are recorded webinars for more detailed information. And next webinar with some really good use of these tools will be done on May of 31st of May, and of course I will be your trainer. So if you would like to discuss even further, we can see on that date. And with this, we have came to the end. So if you have questions, please do not hesitate.
Okay, thanks, Vladimir. Yeah, I've just noticed in the sidebar on the upcoming training, it says May the 24th. It should be May the 31st. So it's not next Friday, it's the Friday afterwards. But we'll be sending an email out in the next day or two about it. Okay, thanks for that overview, Vlad. Just picking up on a few comments. Sophia, can you see the comments Sophia's made there about Fishbone and FMEA are different? FMEA is proactive. Fishbone, 5 whys generally used when there is an issue and need to determine root cause. That's a good point, that actually, isn't it? Yeah. The FMEA is looking at possible root cause and prevention before it even happens, I suppose. Sometimes, if you're designing, if you like designing a new process, or bringing in a new whatever factory.
Yeah. So the thing would be that if you are developing some new product, you use FMEA and practically put all possible issues that could happen, and then you go, let's say, in front of it and try to find and to prevent everything of happening. I just wanted to show you through this project that practically you can use FMEA even for the things that already happened, and try to prevent it in the future of happening it again. So practically, this is why FMEA in this case is a little bit used differently. Yeah,
but like you say, sometimes you have that many problems, it's difficult to prioritize and where you would use FMEA. But obviously, if you've got a recurring, like that example that you gave, a recurring big issue and you just can't get to the bottom of it, that's really useful as a team to do that.
For example, someone mentioned that that FMEA is similar as the HCCP, and this is hazard analysis. But practically, it is. You can use the FMEA to analyze all the hazards, to really put the practical preventive actions that you are already using, etc., and to really see, do you have any detection on your production, or you just need to implement it, and here important thing is that we always in hazard analysis are using like only two measures, and we somehow forget this detectability, you know, and because of this, sometimes our hazards are evaluated higher with a higher risk priority number, and sometimes we have CCPs that, you know, maybe could be controlled on some other levels or through some preventive actions, etc.
Okay. One from Darla. I don't know if you can see that, Vlad.
Yes.
On the example of FMEA, if the improved state cannot be reduced to under 250, would creating CCP be the appropriate correction?
Yes, it could be appropriate correction, but again, I would recommend that you use a decision tree in this case to again just evaluate, do you have any next step where you could remove this critical control point. But of course, you are right, you could create a critical control point.
Yeah. Just a couple of nice comments there. Sabina, thanks. I liked how you linked FMEA with the Ishikawa diagram, and Nicola, thank you for practical session and good explanations. Michael Rodriguez, FMEA is like risk-based thinking to identify possible hazards that could cause problems that would need preventative actions.
Yes.
So, and Roberto, I don't know if you can see that. With FMEA and Ishikawa, I could use Pareto chart in order to attain the highest score.
Yeah. Yeah, it could be too. You can use it with FMEA, Ishikawa, also Pareto charts, because all of these total quality management tools, you can combine it together, you know, and sometimes because we in production or in retail, we don't have time, you know, to analyze it very for a long time, some compliance or some issues, because we have small time amount to answer the complaint for the customer or something like that, and to really resolve the problem, you know. So the most important thing is would be that you really combine all of the tools that you can.
Mm-hmm.
Yeah.
That's a point from Suhail. I'm just a fresher to the industry. How far is this important at audit point of view?
Yeah, at audit point of view, because I had some audits. I think it was focused on BRC. I'm not the auditor, but with the auditor for BRC. And for example, in this, it is needed that you show why did you implement some of the measures in your process. For example, why did you decide that something is a CCP? Why have you, or maybe if you implement some measure of pasteurization or something like that, before the implementing of this step, you need to explain why did you implement it. And the FMEA is good here because you can show through this second part of FMEA. First part is to really show the risk priority number, and the second part is that you implement some measures. For example, you implement metal detection, you implement I don't know, pasteurization, something, and then you show that the risk priority number is low. So this is practically the step where you could use it. But in auditing of the simple standards, like let's say HACCP system and just ISO 22000, etc., you would not need this detailed hazard analysis. You know, you can use some simpler one.
Yeah, I mean, we've got to say FMEA is an advanced tool.
Yes,
but ultimately, in any business, there will be problems, non-conformities, internal, customer, and if you don't get to the root cause of the problems, you'll forever be in a mess. Cost, complaints, unhappy customers, even lost business, etc. So. You have to take the time to get to the root cause, and the more time and effort you spend on root cause actually you then buy time for yourself, don't you? Because if you just
Yes,
end up,
yes,
suppose if you just end up putting weak corrective and preventive actions in, you're just forever in turmoil.
yeah.
Yeah.
Okay, so is it better to use the, yeah, I saw one question, how long did it take to resolve this issue? And I must say, because of the all proposed measures that we needed to implement, like to buy some conveyors, to find some additional cleaning agents that are different, to train the employees, we needed about 2 months to implement everything. But after we started implementing just one of them, the most critical ones, we try to implement the first, and after removing just one of them, the second one, the third one, we had a lower number of non-conformities already. Already customer complaints getting lower. Already we implemented some additional controls on the field, etc. It needed a little bit longer time because of the measures. We wanted to be sure that this will not happen ever in the future. This is
Yeah.
this is why it lasted for I think 2 months. Yeah.
So it's worth the hard work and effort. It pays off.
Yeah, yeah.
Liz Lee is saying this is a very good way to document all corrective actions and the follow-ups, if effective. Industry so many corrective actions that at one point which was the right action.
Yes, yes, it is. It is a good way to
Yeah.
document it. Yeah. There is a lot of templates that you can download it on the internet and really adjust it to your industry and your organization and really use it on an easy way.
David Gregerson, the Band-Aid effect, you must treat the illness, not just the symptoms. Yeah.
Yeah.
And then Shwetha is asking, is it better to use FMEA after CCP tree or better to use only one of them?
But actually, you are using the CCP tree after you perform the hazard analysis, and you can use the after you perform the hazard analysis and you think maybe it is a CCP because of the calculation, you use the decision tree just to be sure, is it or it is not. But again, after you have done the CCP tree, you can come back to FMEA and really do again the calculation, because now with the CCP tree you said, okay, but there are some additional measures that I'm doing, and I have a detectability actually in my production that I didn't think about before the calculation, and again came to FMEA.
Just a question, Vladimir. We've done an hour today, and there's been a lot of interest in. There's been quite a bit of interest in the FMEA, but you've only been able to go into it in certain low depth. If somebody attends on the May the 31st for the 4-hour session, what more will they be able to get out of it?
Yeah, so this time we only talked about, Ishikawa for a short period of time and FMEA for in 1 hour. We tried to pack it in one project, but over there we have 4 hours. We will have FMEA for a whole 1 hour. So we are going to talk about how do you really perform the evaluation, what are the each step of performing the FMEA, from the defining of the team to the use of templates. We are going to show like 4 or 5 different templates for the FMEA. Again, we are going to talk about this project, but more detailedly. And in Ishikawa, again, we are going to talk about different uses of Ishikawa for different kinds of aspects. We are going to talk there about problems with packaging, problems with the design, etc. So for each of these tools, we are going to talk about for an hour.
Okay, well, so if you're interested in that, that's May the 31st. It's in the sidebar. You can click the link to find out more. It's $97, and if you do purchase that, you've got access to it for 30 days as well. So are there some templates as well, did you say, in there?
Yes, it will be a lot of templates to download for each of these tools. templates will be available in the download section for that 31st of May. Really easy to use, that could be easily implemented, you know. And the important thing is that for this and for that webinar, all of you will have a contact with both of us. So if you try to use that in your production, you can always contact us by email or something, and we can talk how to really solve your and find your root causes and solve them.
Okay, super. Any further questions for Vladimir while he's here, ladies and gents? Can you see any more there, Vladimir? That we have gone over the time. Just lots of nice comments in the sidebar. You know, great practical explanation. I think it really helps because it is, you know, some of the tools can be complex, and to see practical examples is really meaningful. Sinks in a lot more. So yeah.
I remember when we started with this, we started with some general explanations, and we started with some general, you know, things to show. But at the end, we came to some really practical things that is needed for industries.
Yeah. Okay, Vlad. Oh, just a minute. Roberto, question. Can you see that? The values of high, medium, low apply to all industries, food, drinks,
yes,
etc.
applies to all industries, but when you define the theme, when you sit, you could say, okay, what is high for us? Maybe 1,000 is not high for us. In some cases, you can say 250 is very high for us. It depends on the type of the issues in your industry, and it depends from your customers.
Okay, yeah.
You know, the more demanding customers, the more risks higher.
Okay, yeah. Chris, this would be a great tool to use in conjunction with your complaint systems.
Yes, yes.
And eliminating these complaints. Yeah.
Yeah.
Okay. Mari Carmen Miranda, yeah, there's probably templates in Spanish for FMEA on the internet.
Try to find it on the internet. There are probably.
Okay, Vladimir, thanks very much. I'll be working with you again on May the 31st for the 4-hour training. But for now,
thank you all again.
Much appreciated, Vladimir.
Okay,
excellent.
Bye-bye to all. Thank you.
Thank you. That was Vladimir Suchinsky, another nice webinar. We'll follow up with an email later on today with the recording, the slide deck, and the certificate. And I'll put a link in there to the training course on May the 31st. And thanks for your attendance today. I hope you got a lot out of it. We'll see you on the next one. Happy Friday. Have a great day and weekend. Bye.